Alright guys, welcome to the Pre-algebra 9.3 video. We're talking about the Pythagorean Theorem, okay? So what is the Pythagorean Theorem and what is it good for? Well, we use it when it comes to right triangles, okay? So it's used with right triangles. Okay, so what is a right triangle? Well, it's a triangle that has one right angle, right? There's a right triangle, and even that would be a right triangle. Okay, so we use it with right triangles, but what is it used for? Well, it's used to calculate the length of any side of a triangle. Okay, you just calculate the length of any side of a triangle. Okay, so what is the Pythagorean theorem? Well, it states that a squared plus b squared equals c squared. And what does that mean? Well, we're talking about what with Pythagorean theorem? Right triangles, okay? Here's a rough sketch of a right triangle. And let's see, the theorem, a squared plus b squared equals c squared. So I see 1, 2, 3 terms here. And conveniently enough, well, there are 1, 2, 3 sides of a triangle, right? So what it means is that if I take this side, which is, we're going to call him A, okay, and it's one of the legs of the triangle, and I add to it, and I square it, okay, so I take the length of this side and square it, and I add to it this length down here, which is B, and I square it, what it will equal is this length right here, which always has to be C, squared, okay? So this, the length of this squared plus the length of this squared will equal that squared, the length of the hypotenuse. So we call that longest side of the triangle, which is also directly across from the right angle, the hypotenuse. Okay? All right, so there you go. It's always the longest side, and it's always directly across from the right angle. Okay, so let's work on a problem. So let's say we have a right triangle. This side is 3, this side is 4, and what we want to know is how long is that side. Okay, and there's our right angle. So the question is, what side are we finding? Well, this is a leg, and this is the what? Hypotenuse, right? The hypotenuse is going to be the longest side, and it's directly across from the right angle. So how do we do that? Well, we use the Pythagorean theorem, and it states that a squared plus b squared equals c squared. Okay. Now, a squared, you could always, go with this side, but the triangles are going to look different sometimes, so I just want to make sure we understand that it is one of the legs of the triangle, and then b would stand for the other leg, and then c would again be the hypotenuse, Hypotenuse. Okay, so we're going to plug in what we know. Do I know one of the legs of the triangle? I do. Let's use that one. Okay, 3. So we're going to put 3 in there, but again, we have to square it. All right, plus, what's the other leg? Well, it's going to be that one right there, and it's 4, but we got to square it as well. And that equals the length of the hypotenuse. Do we know the length of the hypotenuse? No, we don't. So I'm just going to use x. You could use c if you want. And we're going to square that as well. We can't get rid of that squared. All right, so what do we do? Well, let's evaluate this thing. What is 3 squared? It's 9. Plus 4 squared is 16. And that's going to equal x squared. All right. So what is 9 plus 16? Well, that gets you 25 equals x squared. And then you got to do what? Well, x is the variable here, and it's not by itself, so we need to put a square root or a radical sign over both sides in order to cancel that squared, so that x will now be by himself, because a squared inside a square root cancels. And that equals, well, what's the square root of 25? It's 5, right? But think about this. We are solving an equation, and remember what happens when we solve an equation and use radicals. I got to have plus or minus there, okay, plus or minus. So technically, my answer is the positive and negative square root of 25. The positive square root of 25 is 5. The negative square root of 25 is negative 5, okay, because both 5 times 5 is 25, and negative 5 times negative 5 is also 25. But let's think about this. We are talking about a triangle, right? Could I have a negative length of a triangle, of its hypotenuse? No, I couldn't. So even though we're solving an equation, and I said when we solve equations, you get two answers, we're only going to accept the positive answer, okay? So what we're going to really say is that x equals 5. Okay, so what does that mean? Well, it means that length right there is actually 5. Okay, and we can check our work because this squared plus this squared must equal that squared. So does 3 squared plus 4 squared equal 5 squared? Well, let's see. That's 9 plus 16, which equals 25, question mark. Well, that's 25, and 25 does in fact equal 25, so we did it correctly. I should have noted this would be item number 2 here, and we're moving on to item number 3. So we found the length of a hypotenuse, right? So what we're going to do now is find the length of a leg of a triangle. Okay, so we're finding the length of a leg. So let's see. We'll do 10. Okay. Here we have a triangle, and let's say the hypotenuse is 12. Let's say one of the legs is, we'll do 10. All right, and what we want to know is this guy right there, okay? So I don't know that, so I'm going to put an x there as a variable. So how do we find that length? Well, we're going to, again, use the Pythagorean Theorem. And so what does that state? Well, again, a squared, or one of the legs squared, plus the length of the other leg squared has to equal the length of the hypotenuse squared. So do I know one of the legs? Yeah, I do. It's that one, right? It's 10. So we're going to plug in what we know. Let's see, 10 squared plus, what's the length of the other leg, though? It's x. We don't know, and that's okay. We're going to put x squared, all right? And that equals the length of the hypotenuse squared, so that's 12, and we're going to square it. So now we got to solve this equation, right? So let's see, 10 squared would get you 100, plus x squared, it's just x squared, equals 12 squared is 144. So we have an equation, and we're still solving for x. So how do I do that? Well, let's think. I have 100 here plus x squared, so I got to get rid of a couple things. I have to get rid of this 100, have to get rid of that squared in order for x to be by itself. So what we're going to do is, again, kind of like when we learn in solving equations, the opposite of order of operations. I know I have an exponent here, and I'll have to subtract this 100. And instead of doing the exponents first, like I would in order of operations, I'm going to do the subtraction of 100 first. All right. So let's see, 100 minus 100 is 0. So I'm just left with a positive x squared, and that equals 144 minus 100 gets you 44, right? So what's the next step? Well, you have a squared here. You've got to get rid of that squared. How do you do that? Radical sign, or square root sign, right? So the square root of a squared term, square roots cancel, so you're left with x. And that equals the square root of 44. Is 44 a perfect square? No, there's no positive or negative non-decimal number. Okay, there's no integer that you can square to get to 44. Right? So what do we do? Well, let's see. Let's break 44 up into the multiplication of two numbers. So how about 4 times 11? Well, let's see. If I do that, that's going to be, that's like saying the square root of 4 times the square root of 11, right? So that's really like saying square root of 4 is 2 times the square root of 11. I can't change that at all. I can't simplify the square root of 11, so I just leave it, right? But here's the thing. We took the square root in an equation, so really we have technically two answers, right? Okay, so what we have is a positive 2 root 11, but I could put in a negative 2 square root of 11. And it might look a little confusing, but what I'm doing up here is there is the same thing we did up here. When we took the square root of 25 and the square root of x squared, we had to add that plus or minus because we were putting a square root sign into an equation, and we said, oh, okay, you have two answers here. 5 or negative 5. Okay, but remember, we only took the positive number because you cannot have a negative length of a triangle, right? It has to be positive 5. It wouldn't make any sense if the length of that triangle were negative 5. So we're going to go down here and say, well, which one makes sense? Okay, if I'm solving for that length of that triangle there, does negative 2 root 11 make any sense? Well, actually, take your calculator and plug that in real quick. Plug in negative 2 root 11, and what you should see is negative 6.633, so on and so forth. It keeps on going, right? So does that make any sense that that length would be negative 6.33? No. But how about positive 2 times the square root of 11? So we're working on that right there. You plug that in your calculator, that gets you positive 6.633, and it keeps on going. So these two numbers are exact opposites of each other. Okay, but we take this one as our answer because we're talking about a real triangle here, so it must have a positive length. All right, so this would be the rounded or approximated answer, but really this is a good answer for us right there, 2 root 11. Now I know that's not an integer, but it's really the most accurate answer because we simplified our square root down and got to 2 root 11, and that really reflects the correct, totally correct answer. So you could put that there, but if it did say like approximate your answer to the nearest thousandth, this would work as well. All right, so I want you to take a second. I want you to work on this problem, okay? I want you to just figure out if the following dimensions form a right triangle. So I've given you the lengths of the legs and the hypotenuse, and so I want you to figure out if these dimensions form a right triangle. Play the video when you're done. All right, so what I would say is that, well, I know for a right triangle, we use the what theorem? The Pythagorean theorem, right? Pythagorean, and that states that a squared plus b squared does equal c squared. So what is a in this case? Well, they say it's 3, so let's take 3 and then square it. Plus, what is b? They say it's 5, so we're going to put in a 5 there and then square it. And they say c is 7, so I'm going to put in a 7 there and square it. So what we're going to figure out is this equal? Is one side of the equation equal to the other? So 3 squared is 9 plus 25 equals 49, question mark. So what is 9 plus 25? Well, that's 34. And does 34 equal 49? No, it doesn't, right? So what will we say about these dimensions? Well, we would say, hey, they don't form a right triangle because when you plug those dimensions into the Pythagorean theorem, you get a false statement. All right, so lastly, what is the longest side of a right triangle called? And where is it? Well, again, it's directly across from the right angle, and it's called the hippopotamus, right? Hypotenuse. Hypotenuse. But if you want to think about it as the hippopotamus, if that helps you remember, that is totally okay. All right, guys, that's all I have for you. I will see you in class.